Hello students. Today our discussion topic is classification of water. We know rainwater contains purest form of water which mainly contains some dissolved gases from the atmosphere. Hence, it acts as a good solvent. Water dissolves many salts of calcium and magnesium. Water can be classified into two categories. First, hard water. Second, soft water. Hard water is the one which does not produce lather with soap readily. Hard water contains salts of calcium and magnesium in the form of hydrogen carbonates, chlorides, sulfates. It does not give lather with soap and hence it is not suitable for laundry purposes. It is not suitable for boiler. What is boiler? Boiler is a closed vessel where water or other fluid is heated. Soft water is the one which produces lather with soap. Soft water is the water free from soluble salts of calcium and magnesium. It gives lather with soap and hence it is suitable for laundry purposes. It is suitable for boiler even. Now, why is hard water not suitable for laundry? Hard water produces scum, which is also known as precipitation with soap. Soap contains sodium stearate having the formula C17H35COONA, which reacts with hard water to produce calcium or magnesium stearate. Take sodium stearate, react with metal ion. Here it can be calcium ion or magnesium ion. It will produce a precipitate which is also called scum along with sodium ion. Now, why is hard water not suitable for boiler? It is harmful for boilers as well because of deposition of salts in the form of scale. What is scale formation? Now, scale formation is nothing but it is the accumulation of the unwanted material on a solid surface. As you can see in the given picture. Scale formation reduces efficiency of boiler. Now, let's check your understanding level. You've been given 10 seconds to answer. I hope you have got the right answer. The right answer is soft water. Soft water is suitable for boiler. Moving ahead, we have next question for you. What is the chemical formula of sodium stearate? 4 options given. I hope you got the right answer. The right answer is B, that is C17H35COONA. Now let's talk about hardness of water. It is of two types, temporary hardness and permanent hardness. Temporary hardness is due to the presence of bicarbonates of magnesium and calcium. That is magnesium hydrogen carbonate or calcium hydrogen carbonate. Temporary hardness of water can be removed by two processes. Number 1, boiling. When temporary hardened water is boiled, bicarbonates of calcium and magnesium decompose to form insoluble calcium-magnesium carbonates respectively, which then filtered off to produce the soft water. It is because of low solubility product of magnesium hydroxide as compared to that of magnesium carbonate. We are taking magnesium hydrogen carbonate. When heated, it produces magnesium carbonate along with water and carbon dioxide. And calcium hydrogen carbonate, when heated, produces calcium carbonate, water and carbon dioxide. And these two are the precipitates formed which can be filtered off, and thus soft water can be generated. Second method is called Clark's method. This method is used on a commercial scale. In Clark's method, a calculated quantity of slag lime is added to hard water. It precipitates out calcium carbonate and magnesium hydroxide which can be filtered off. We're taking calcium bicarbonate, react with calcium hydroxide, which is also known as slag lime. It will produce calcium carbonate as the precipitate along with water. Similarly, magnesium carbonate when reacted with calcium hydroxide produces calcium carbonate, magnesium hydroxide and water. However, if excess of quicklime is added, water will again become hard due to the absorption of carbon dioxide. It's a very important point. Now, calcium hydroxide we have. Now, if excess of carbon dioxide is produced, so calcium hydroxide will now react with carbon dioxide to produce calcium hydrogen carbonate, which is nothing but calcium hydrogen carbonate, and because of which the water again turns into hard. Now, permanent hardness. Permanent hardness is due to the presence of soluble salts of magnesium and calcium in the form of chlorides and sulfates in water. It can be removed. It cannot be removed by boiling. It can be removed by the following methods. Number one method is treatment with washing soda, which is also called sodium carbonate. Washing soda reacts with soluble calcium and magnesium chlorides and sulfates in the hard water to form insoluble carbonates. The reaction where you are taking metal chloride or metal sulfate, in this case metal is magnesium or calcium, and we are getting the corresponding products. And these are the insoluble products, so it can be easily filtered off to convert the hard water into the soft water. Next method is Calgon method. Now, what is Calgon? Calgon is sodium hexametaphosphate. Please remember the formula. It is Na2Na4PO36, or in simple Na6P6O18. When Calgon is added to hard water, the following reactions occur. This complex anion keeps the magnesium and calcium ions in the solution. Now, next method is ion exchange method. So this method is also called zeolite permutate process. Hydrate sodium aluminum silicate NaAlSiO4 is called zeolite. When zeolite is added in hard water, exchange reactions take place. So you can see the reaction, what is happening here, and there's the exchange of the metals now. Sodium will be replaced by magnesium ion or calcium ions, thus producing MZ2. It may be calcium Z2 or magnesium Z2. Zeolite will get exhausted when all the sodium in it is used up. To rectify this problem, aqueous sodium chloride solution is added, which regenerates zeolite for further use. So this is the experimental setup of permutate process for water softening.